Okay, 10.3 properties of logarithms. Students will be able to simplify and evaluate expressions and solve logarithmic equations using the properties of logarithms. So we have a few properties we're going to learn here. These are ones that can be really easy as long as you remember them. I'm going to say this. Remember back in the day we had like x squared, let's not say plus. How about times x cubed, right? X squared times x cubed. What would we do? Well, we would say, oh, that's like adding the exponents because we multiplied the x's so we could add the exponents. Okay. Well, the same thing is true here. Logs are really just exponents. So if we were going to be adding logs, that must mean we were multiplying our bases or multiplying our results. So if we get this first property that just says the log b of m times n is the same thing as separating them out as the log b of m plus the log b of n. Even though they are multiplied in here, we could add them as logs. So let's do that. Here I have a log base 4 of 7 times x, so that means that I could write this as log base 4 7 plus log base 4x. That's it. Go ahead and do the practice number 1 on your own, and I'll put the answer up there in just a second, so you may want to pause the video. Okay, so we have 32 times x times y, so that's the same thing as log base 32 plus log base 2x plus log base 2y. Simple as that. You can expand it. Alright, so now let's put them together. Well, here I have two logs added together. They have the same base, so I could write this as log 7 6a. And now the 6a are part of this log. One single log. So go ahead and try practice number 2. Pretty simple. I'll put the answer up there in just a second, so you may want to pause the video now. Okay. Combine it as log RST. Now you may notice there's no base here. We call those common logs. We'll talk about that more next lesson. But basically that means that there is a base of 10, and we don't really need to write it when it's a base of 10. Okay, what if we get a problem like this? They say use the fact that log base 2 of 3 is approximately 1.5850 and approximate the value of log base 2 of 48. Okay. Let's think about some things here. How could I factor down 48? Because now we know what to do when things are multiplied together inside of a log. So maybe I could write this log 2 48 as a couple factors. Like maybe I could factor down 48 as 24 times 2. And then I would be able to write this as log base 2 of 24 plus log base 2 of 2. So we're going to keep factoring this down, see what we can get to. Well, 24 is 12 times 2, and 12 is 4 times 3, and then that's 2 and 2. So we could change 48 to 1, 2, 3, 4. 4 2's. So it's safe to say that 48 equals 2 to the 4th power, because there's 4 of them. So 1, 2, 3, and 4. Times 3. So that means if I wanted to write this whole log here, log 2 48, I could write it as log base 2 of 2 to the 4th times 3. And then I could keep going with this because I could split it off. I could say, hey, that's like log base 2 of 2 to the 4th plus log base 2 of 3. And look, they told me what log base 2 of 3 was right here, so I just got to figure out what this is. Well, let's think about what this really means. First of all, I could break this off into several log base 2's, right? Couldn't I say that this is like log base 2, 2 plus log base 2, 2 plus log base 2 of 2 plus log base 2 of 2, and then over here I can put my log base 2 of 3. So that's really what 2 to the 4th power means, right? 2 times 2 times 2 times 2, which really means log 2 plus log 2 plus log 2 plus log 2. Okay, so what is log 2 of the 2? Well, okay, let's just think about that. anytime you have a base with the same number inside the log, what does that mean? Well, let's rewrite it in exponential form. This would mean 2 to the power of x equals 2. So what power do you raise 2 to get it back 2? Well, 1. 2 to the power of 1 equals 2. So that means that this whole thing just equals 1, which means that all of these guys just equal 1. So really you just have 1 plus 1 plus 1 plus 1 plus 1.5850. Okay, so let's add that all together and you get 1, 2, 3, 4, 5.5850. So the math isn't really hard there. We just had to factor it so we could rewrite that in a way that we could break down. And once we break it down, it's simple as just adding 1 plus 1 plus 1. So we can do that. That's pretty simple. And if multiplying means adding, what do you think dividing inside a log means? Hopefully you're looking at it right now and you see that that means that we are subtracting. So let's give you some examples. Log base 4, 7 divided by 3 could be written as log base 4, 7 minus log base 4, 3. Okay, so you guys are going to do practice number 4 here. Try it on your own real quick. You may want to pause the video because I'm going to put the answer up in just a second. Okay, so you should have just said log base 11x minus log base 11.4. That's all there is to it. Okay, so let's simplify these guys. What if they're already separated and they're saying log base 7.4 minus log base 7d? Well, we would write log base 7, 4 divided by d. That's 1 log. Go ahead and try practice number 5 on your own. Again, you may want to pause the video because I'm going to put the answer up in just a second. Okay, we have an r minus a 3, so that's going to be log r divided by 3. All there is to it. Okay, on this one, don't try and do it yet because there's a typo. So cross off all this. You're going to use the fact that log base 3 of 5 equals 1.465 and that log base 3 of 20 is approximately 2.7268, and we want to know what the log base 3 of 4 is, or at least what it approximately is. Okay, well, think about what we just learned. How could we get to 4? We have a 20, we have a 5. Isn't that the same thing as 20 divided by 5? Isn't that a 4? So we could say, hey, log base 3 of 20 divided by 5 is the same thing as log base 4, which means that's the same thing as log base 3 of 20 minus log base 3 of 5. And now all we have to do is do 2.7268 minus 1.4650. I like doing those on top of each other. It just makes it easier for me. 2.7268 minus 1.4650. Let's subtract 8 minus 0 is 8. 6 minus 5 is 1. 2 minus 6, we got to borrow. 6, 12, that's 6. 6 minus 4 is 2. 1.2618. That's my answer. This is approximately equal to log base 3 of 4. Now, some of you guys are probably wondering, why didn't I just plug this in your calculator? Well, this whole lesson is all about learning what to do with logs when you don't have a calculator. So these will definitely show up on a quiz when there's no calculators being used. Okay. So here we have a word problem. It says the loudness L of a sound in decibels is given by L equals 10 log 10 R, where R is the sound's relative intensity. So right away we already see we're going to be using this equation. So let's write that down. Log 10 base 10 of R. Okay, now let's see what they're asking. Suppose one person talks with a relative intensity of 10 to the 6, so their relative intensity is 10 to the 6, or their L in decibels is 60 decibels. Would the sound of 10 people each talking at the same intensity be 10 times as loud, or 600 decibels, right? So would it be 600 decibels because that would be 10 times as loud as 60? Explain your reasoning. Well, let's think about this. If one person talking is 10 to the 6, and then we have 10 times that means my relative intensity is going to be 10 to the 6 times 10. So let's write that. L equals 10 log 10, and then my relative intensity is 10 times 10 to the 6. Well, how could I write that? Well, that's the same thing as 10 to the 7th, right? 10 times 10 to the 6. So I'm just going to say L equals 10 log 10. That's a 10 still, of 10 to the 7th. Well, we learned a bit before that when we have 10 to 10, this whole thing just equals whatever's up here in the exponent. So this whole thing is just 7. So I can write right here, this is just 10 times 7, which means that this answer is just, not 60, 70 decibels. So the answer is no. No, it's not 600 decibels. In fact, it doesn't get multiplied by 10 times as much. It just goes up by 10 decibels. So that's right, because we're dealing with logarithms here, which are really powers. So multiplying something by 10 doesn't really make the decibel value 10 times as loud. It just makes it go up by 10. So kind of interesting. Good little problem, good little way to think about it. But just remember, they're usually going to give you the formula that you're going to use or the equation you're going to use in the problem. So be looking for that, okay? All right, here's the last one. We got exponential properties of logarithms. So what they're saying here is, hey, let's say you had log base b of m to the x power. You could bring that x out in front and just multiply it by that whole log. Again, that's because, if you remember, what if you had x squared to the 5th power? We said, well, that's the same thing as just multiplying these logs, or these these exponents. That would be x to the 10th, right? A power to a power is like multiplying powers. 2 times 5 is 10. So we have a power to a power. So that's the same thing as multiplying powers. So what do we got here? Log base 4 of 7 to the x power. Well, we could bring that x out in front and write it as x log 4 7. All there is to it. Pretty simple. So why don't you guys try practice number 8 there. See if you could rewrite that as with a exponent instead of a coefficient. Go ahead and try that, because I'm going to put the answer up there in just a second. Okay, so all you have to do is move the -3 up here as an exponent to the 5. And remember, negative exponents mean that it's on the bottom. So you could have written it like this as well. So that's all there really is to that. Okay, so let's try this next one. It says, use the fact that log base 4 of 6 is approximately 1.2925 to approximate the value of log base 4 of 36. Well, how could I write 36 with 6's in it? I see that as 6 squared. So I'm going to write log base 4 36 as log base 4 6 squared. And then I know that I could just bring this exponent out in front. And so I'm going to write that as 2 log 4 6. And I already know what log base 4 6 is. It's going to be 1.2925. So all I have to do is double this whole thing, and I have my answer. I'd rather just add instead of doubling, right? If I just add another one to it, it's the same thing as doubling, so I'm just going to do that. 5 plus 5 is 0, carry the 1, that's a 5. 9 plus 9 is 8, carry the 1, that's a 5. 2.580. There we go. 2.5850. All right, now let's put it all together here. We got a few little things we got to try here. What if we were going to expand this guy? Log base 3 5x squared. Well, first, the square is only going to the x, so don't move it out front yet. But we could go like this. Log base 3 of 5 plus log base 3 of x. And then, instead of putting the 2 here, we can move that out in front. So that's what that would look like expanded. All right, so I want you guys to try this one. Remember, you are dividing. So see if you can figure this out. What are you dividing by? So what should be positive, what should be negative? Just think about that. Go ahead and give it a try. I'll put the answer up in a second, so you may want to pause the video. Okay, so there's a few different ways to think about this one. I like to think that if it's on the top, it's a positive exponent, and if it's on the bottom, it's a negative exponent. So let's do it that way. I have log base 2 of a cubed. That's my positive one. And then on the bottom, I have log base 2 of b. But it's on the bottom, so that means I'm going to subtract because I divided. C is also on the bottom, so I'm going to have log base 2 of c to the 4th, and I'm also subtracting that one. So positives are on top, negatives are on bottom because that's the same thing as dividing. So I could write these moving the exponents up in front, and I'd get 3 log 2a minus, this one doesn't have any exponents, so just log 2b minus 4 log 2c. And now that thing is expanded. All right, let's simplify these expressions here. This one, we have the same log base, but this 8 is out here, so I'm going to have to move the 8 out in front to get log base 4, 3 plus log base 4 a to the 8th, and now we can combine it as log base 4, 3a, 8. Okay, so once you guys try practice number 1, you got some subtracting, you got some adding, you got a positive one, so you should figure out which one goes on top, which one goes on bottom. Go ahead and try it. Again, I'm going to put the answer up in just a second, so you should pause the video now. Okay, so I wrote it with the exponents up on top, and then I'm going to put all the positives on top. So I got log, x4 was a positive log, and z to the 3rd was a positive log. Y to the 5th was a negative log, so I'm going to put that one on bottom. And there we go. So that's how you would do that one. All right, lastly, we're going to solve some equations. I'm going to solve this one with you guys. So let's simplify it first. Right, we can see that we are dividing here, but this is actually a typo. So let's change that to a plus. I apologize. That was supposed to be a plus. So that means that we're actually multiplying. I'm looking at my hard copy notes and realizing that was a typo, so I apologize about that. So we can combine these to multiply. Log base 4x times x minus 6 equals 2. And now we have a situation where we don't have a log on this side, and we have a base, and we have an exponent. So we can rewrite this whole thing to be 4 squared, right? Because there's my exponent. This is really 4 to the power of 2 equals whatever's inside my log. So this would equal, let's distribute that x. That would be x squared minus 6x. Okay, well, this is a quadratic, so we're almost there. The only problem is we got to get quadratics that equal to 0. So before we can do anything, we got to subtract 16 from both sides, because 4 squared is really just 16, right? So now we get 0 equals x squared minus 6x minus 16. So the question is now, can we factor this whole guy? Well, is there something that multiplies up to negative 16, adds up to negative 6? How about 8 and 2? How about negative 8 and 2? So x minus 8, x plus 2. Does negative 8 times 2 equal negative 16? Yes. Negative 8 plus 2 equals negative 6? Yes. Therefore, x equals 8 and negative 2. All right, the only thing is you can't really have negatives inside logs. You can't, if we take this negative 2 and plug it back into log base 4 of x, we would get undefined. So we can't have negatives in logs, so we could go ahead and just eliminate that as an answer. And the real only answer here is that x equals 8. Okay. So we're going to go ahead and try practice number 12. I'll put the answer up in just a second, so go ahead and pause the video. Okay, so I moved the exponent up here, and now I told you if we got a negative log, right, that means it goes on the bottom. So these are the same base, so we could do log base 5 x cubed divided by 4 equals log base 5 is 16. And now once you get it like this, where there's just a log and then something inside it, if these are the same and these are the same, then that means whatever's inside here has to be equal to what's inside there. So we could say, hey, x cubed over 4 has to equal 16. Multiply both sides by 4. X cubed equals 64. Take the cube root of both sides, and you get that x equals, not 8, sorry, x equals 4. So the cube root of 64 is 4. So there's your answer. That's a positive number. We can plug it right back in. It won't be a problem. So x equals 4 is your solution there. All right. There's all the information for 10.3. And I'll see you guys on the next video.